Okay guys, we are going to talk about speed and velocity on this first video. This is something very easy for you to get because it's something that affects your life every day. Okay, get my camera fixed here. Alright, so the first we need to go over the definition of speed. Speed is a measure of the distance an object travels in a unit of time. So again, this is something very easy for you to think about because this pretty much affects you all day, every day. When you're walking in the hallway, you're traveling a certain amount of distance in a certain amount of time. Okay, when your parents pick you up from school or take you to school, you are traveling a certain amount of distance. Your speedometer says miles per hour. That is your distance per time. So how far can your car travel in a certain amount of time? Now to calculate speed, we again just use our distance divided by our time. Okay. Again, because speed is a measure of how much distance we're going to travel in a certain amount of time. It's a rate. Okay, you've all learned rates in math, so this is just another rate. Okay, our units are going to always be a distance per time. So for example, here, hang on, okay. Okay, hopefully we got our issues fixed. Okay, going back, so our units are going to be distance per time. So example here is meters per second. Like we talked about your car, miles per hour. But remember in science, we use the metric system. So a lot of things that we're going to be looking at are going to be, for our distance, are going to be meters or kilometers and things like that. All right, to help you calculate, when we calculate, we draw this nifty little triangle. And we have to make sure that we put the distance at the top. Speed and time can interchange with each other, but it's very important that we put the distance at the top. Okay. How we use this triangle is we cover up whatever we're looking for. So if the question is asking for distance, we would cover up distance. And if the two letters are beside each other, we multiply. Okay, so these two we would multiply if they're beside each other. So in order to find distance, we'd multiply speed times time. If we cover up a letter, let's say we cover up speed, we're looking for speed in the problem. We have distance over time. When they're on top of each other, we divide. Okay? Accordingly, if we're looking for time in the question, we cover up time. We have distance divided by speed. Okay? We have what's known as instantaneous speed and constant speed. Instantaneous speed is any speed that you're going at that exact instance. So that's kind of easy to remember. Constant speed, okay, is where you're going or something is moving at the same speed. It's traveling the same amount of distance every time unit. So if you get on the highway with your car and you're driving 60 miles per hour and you travel 60 miles in that 1 hour, then you were at a constant speed. You covered the same amount of distance in a certain amount of time. Let's say you went 60 miles per hour for 3 hours, then that means you were at a constant speed because you covered the same 60 miles every hour. Velocity. Okay, velocity is basically just speed plus direction. So our speed in a given direction. Okay, so that means we can change our velocity if we speed up, if we slow down, or if we change our direction. Those are the three ways that we can change our velocity. An example of velocity would be our speed plus direction, like I said. So if we're going 75 kilometers per hour, in order to make it velocity, we would add on our direction. So we're going 75 kilometers per hour west. This doesn't always have to be a cardinal direction. It could be up, down, left, right, or turn around. Okay? Acceleration is our change in speed. So you've all heard of this before. When you speed up, you're accelerating, you're getting faster, you're not going at a constant speed. Your rate is changing. It does not stay the same rate anymore, or unit rate. Okay, so we can change in speed or direction. So how we change our acceleration is if we speed up, we slow down, or we change our direction. An example of a unit of acceleration would be 75 kilometers per second squared. Notice this squared. This is very important to tell the difference between the acceleration units and the speed units. Okay, that squared helps us tell that we're changing that speed. We're either slowing it down or speeding it up. Okay, we're changing the rate. So let's practice real quick. Okay, 75 kilometers per hour. Which one of those? Is it speed, velocity, or acceleration? Correct, it's speed. Okay. What about 75 kilometers per hour squared? Okay, that is acceleration because we have that squared on there. And what if we're going 75 kilometers per hour west? That should be velocity. Okay, now one quick thing, going back up here, I forgot. When we slow down, we call it deceleration, so we decelerated. When we speed up, we call it acceleration. Okay, so we're changing our rate, not constantly. Maybe we were going 60 miles per hour, and now we're going 67 miles per hour, and now a second later we're going 73 miles per hour. We're speeding up, we're changing that unit rate. All right, let's talk about graphs, which we will not do for a couple of days, but it is good for us to go ahead and go over it. Okay, so now the number one important thing when we're looking at motion graphs is to pay attention to our y-axis. Okay, our y-axis is very important because sometimes it will say distance and sometimes it will say speed, right? And that what they say here totally changes what we are looking at. Now, since this is a distance time graph, these lines are representing speed. Okay, these are it's showing our unit rates, how much distance over time. That is, each line is showing our speed. Okay, that's what the line represents. So let's talk about what each line means. Let's look at this hot pink line right here. Okay, first. So this line is a straight line. Okay, now it represents two things. First of all, this is our origin, just like you learned in math, our starting point. Okay, so this pink line tells us, first of all, we are moving at a constant speed. We are changing our rate at the same amount each time. That's where we get our straight line from. So this is a constant speed. And we're also moving away from our starting point. Okay? So we're moving away for something. So this shows this is a stop sign. Or excuse me, this is the school. And this is you traveling at a constant speed to your home, moving away from the starting point. Okay? Now we'll look at the green line. Okay, so straight line again is going to tell us that it is constant. And now we also know that it is moving back towards our starting point. Now a lot of people think because it's going down or this one's going up, this means that this is slowing down and speeding up, not on a distance time graph. Okay, we'll talk more about speed graphs as we get to that point. Okay, then we have this orange line. Okay, this orange line right here, you can see as time goes on, no distance is traveled. So this line means we are no motion. Okay, we're stopped, we're standing still, we're not going anywhere, no motion. Okay, then we have this blue line here. Now you can see it's not a straight line, so we're not changing our rate the same each time. So therefore, we are not staying at a constant speed, but we're speeding up, which means we are accelerating. Now we have this pink line. Again, we're not changing at a constant rate, so this line means that we are slowing down or decelerating. This also means, again, that we're moving away from our starting point, and as we're moving away from our starting point, we're speeding up. So this could possibly be a stop sign, and after we're leaving the stop sign, we speed up to get back up to our speed. Here, maybe we see a stop sign going back home, or we're pulling up to the stop sign. So we're pulling up to the stop sign, we start to slow down until we stop at the stop sign. We're going back to the point. All right, have these ready for us in class on Wednesday.